Let's find the remaining sides and angles of the described triangle. Okay, so we have to be careful. Whenever we are only given one angle and we are having to find two angles, it's possible that we can end up with two triangles that fit this description, okay, where this could be two different angles. Okay, so we need to check for that, okay, and we'll deal with that in a second. So let's start off as we normally would. Let's find beta by using the law of sines. Sine of beta over, let me not put that there, over b, in this case 42, equals sine of alpha, 117 degrees, over a, which is 45. And I'm going to multiply both sides by 42 to cancel this out. So sine of beta is equal to 42 sine of 117 degrees over 45. And then to get beta by itself, I will use the arc sine or inverse sine function, okay, that you see on your calculator. This is another way of writing out arc sine. Okay, and that's what it looks like on the calculator. Okay, so that's what I'm going to type in. Making sure my calculator is in degree mode, I will type in inverse sine 42 times sine of 117 degrees over 45, close parentheses. And I get 56.3 degrees. 56.3 degrees. Okay, so now if beta is 56.3 degrees, then we know that gamma is going to be 180 minus 117 minus 56.3. 180 minus 117 minus 56.3, and that gives me 6.7. 6.7 degrees. Okay, so if beta is 56.3 degrees, then gamma is 6.7 degrees. And then it follows that I can find side C by using the law of sines. I like to use this combination here because I know both of those numbers are right. I don't want to use these numbers because there's a chance that I type something in wrong in my calculator or something, and this is wrong, right? So always use what you know for sure to be the right numbers, and that's the best way to do it. Okay, so C equals, multiply both sides by the denominator, sine of 6.7 degrees. And then I'll type that in my calculator, sine of 6.7 degrees times 45 over sine of 117. And that gives me 5.9. 5.9. Okay, so again, all this depends on if the angle beta comes out to be 56.3. So this all works. This is a right way to work out this problem. Okay, so now let's account for a potential different triangle. Okay, and so what I'm going to do is, well, it kind of just depends on this right here. Okay, this right here. Well, what that came out to be, I'm going to type that in my calculator again. 42 times sine of 117 divided by 45 comes out to be 0.8316 . Okay, that's a bunch of stuff. Okay, and then when I did the inverse sine of that, it gave me 56.3 degrees. In other words, sine of 56.3 degrees equals that 0.8316 and so on. Okay, but it is also true that sine of 123.7 degrees also equals 0.8316 ... Okay, they actually both equal the same thing, right? Because you know how the unit circle works. If we're talking about a point here where the y value is 0.8, well then also over here the y value will be 0.8. Okay, so that's where you have, say, one triangle versus another triangle. Okay, probably a terrible drawing, but whatever. I think you can get the point as far as the y value can be the same. So we need to check. Perhaps, let me kind of go down here, perhaps beta equals 56.3 degrees, but it's also possible that beta could equal 123.7 degrees. Okay, so now I have to check to see if that's a feasible answer, okay, if that's actually possible. So go back and compare. Alpha was 117 degrees, beta 56.3 degrees, gamma 6.7 degrees. Okay, those three will add up to 180 degrees. Everything's normal. But what happens if I add alpha plus this other beta? Well, 117 degrees plus 123.7 degrees will come out to 240.7 degrees. This cannot be a triangle. So that's what you want to do. Let's kind of recap everything that we want to do. So whenever you have more than one angle to find, the first angle that you find, in this case beta, work it out like normal. Okay, we'll call that first angle beta 1. Okay, and work that out as normal. Then find the second possible beta and call that one beta 2. Find it by subtracting 180 degrees minus 56.3 degrees, or let me just call that beta 1. Okay, that's where I got this 123.7 degrees, 180 minus that. Okay, so that will give me my first beta and my second beta. Finally, test it out. Test it out. Add alpha plus beta 2. It has to be less than 180 degrees. It has to be. If not, it's not a triangle. Okay, it's not a triangle. Okay, so in this case, beta 2 added up to something greater than 180 degrees, so this was not describing a second triangle. So therefore, all that goes to say that this right here is the only triangle that I can get from that alpha angle, that side A and that side B.